Okay, now conformational isomerism, I think we have understood. Now in conformational isomerism, I have to discuss a little bit about Newman projection formula. In Newman projection formula, we can get the structures like this. Suppose this is the structure where if you rotate the molecule, then we used to get different conformations. Now you used to rotate the molecule by some angle. Okay, so when you rotate the molecule like this 60 degree, then you will find this structure that we have. This is the structure we used to find. Now this rotation, this angle is called dihedral angle. Dihedral angle. So this dihedral angle, or this is also known as torsional angle. This dihedral or torsional angle. So this dihedral angle and torsional angle gives us different types of structures. Suppose in case of this molecule, we can find different structures. This is called eclipse structure. Eclipsed. This is called staggered structure. Staggered. So there are different types of structures which we can find depending on the dihedral angle. Okay, so it depends also the structure or the types of groups present in the molecule. Suppose if we have only suppose this is your structure. If we have different groups, then we can get different structures. But if we have same group, suppose here all are hydrogens, then some conformations will be similar. But if we have different groups, suppose like this, these two groups are suppose different. One is blue, one is green. So green and blue, that means two different groups are there. This is having a bigger size, this is having a smaller size. So when they will be like this eclipse, definitely there will be some more repulsion. So that is why this molecule will not be very much stable. Suppose if we rotate the molecule like this by 60 degree, this is the dihedral angle, and then it will definitely give you some stability to the molecule. Why? Because they are a little bit more distance apart. So depending on this dihedral angle, we can have different type of structures like fully eclipsed structure, partially eclipsed structure, then Gaussian structure or staggered structure like this. So accordingly their stability will be there. Stability means if they are having this type of distance, there will be minimum repulsion and the molecule will be more stable. Now we will go for another type of isomerism, that is called configuration. We have discussed conformational, now we are discussing configurational. Now configurational isomerism, here we do not have to apply mechanical force. Here we have to do some chemical operations. That means, suppose if we have this molecule, here this molecule is having this yellow ball on this side, and blue, this is one group, this is one group. Now we have to get a structure where this blue should come there and yellow should come here. Now how we can do this? We can do this by using chemical operation. Remember, we cannot do this by just applying some mechanical force or by twisting the molecule. So what is that? This is called configurational isomerism, where we apply some chemical force. Now configurational isomer is the isomer by applying some chemical force we can get, or chemical energy we can get some another structure where the groups will be different in that chiral carbon. Now in this molecule, suppose two types of configurational isomerism is there. One is called enantiomer, another is called diastereomer. So what is enantiomer? Enantiomers are it is said that enantiomers are mirror image of each other and non-superimposable mirror image. So two things we can have to understand. One is mirror image. What is mirror image? Suppose we have a glass mirror and we are putting this molecule here. Now in the glass, if you see, the yellow ball is on my right hand side, on my right hand side, and a blue ball is on my left hand side. But in that picture, if you can see, yellow ball is on your left hand side and blue ball is on the right hand side. So this is the image of the molecule. That means this is that image is the isomer of this one. Okay, but we cannot find this one by using a mechanical energy. We have to find out by using this chemical energy. And what is the concept of superimposability? Superimposable means if something is put above someone, then it is exactly resembles it with each other, and you cannot distinguish in between them. Suppose one ball these two balls are there. These two balls, these are superimposable. If you see the yellow ball, you cannot see the green ball. Okay, but our two hands, they are not superimposable. Suppose if I put the hands like this, they are not superimposable with each other. So this is the concept of superimposability. So enantiomers are the isomers where at least one chiral carbon should be there, and this molecule should not be non-superimposable. Should be non-superimposable, and they are mirror image of each other. Then come to the diastereomer. In case of diastereomers, the molecule generally have more than one chiral carbon, or some molecules are also does not have chiral carbons, but they used to show this isomerism. Diastereomers are the compounds where they are having more than one chiral carbon, and they are non-superimposable, that is the similar condition, and they are not mirror image. That is the main point. Not mirror image of each other. Suppose if we have the example of one molecule, suppose this is a molecule where we have these are the groups present in the molecule. So if we see the mirror image of each other, this molecule, now these two are enantiomers because they are non-superimposable. If you put this molecule above this molecule, then they are not matched. Then they are mirror image of each other. Non-superimposable mirror image. They are called as enantiomers. But suppose if we have this structure, now you see these are not mirror image, but these are the isomers of each other. Okay, what is the change in this carbon? The configuration has been changed. So these two are called diastereomer. They are not mirror image and non-superimposable, and it is having more than one chiral carbon. So see, you can have you are having two chiral carbons in this molecule. So this is diastereomer. Then one more phenomenon is there, that is called geometrical isomer. Actually, that is also a diastereomer. Geometrical isomer. Geometrical isomer means you have found so many examples of this type of molecules, alkenes. So in case of alkene, you have found one example like cis and trans. Suppose if we have two black groups are there and two white groups are there, so these two groups are on the same side, then it should be called as cis. Two groups are on the different, if they are in different sides, then it will be called as trans structure. So these examples you have found earlier also. So cis and trans isomerism is known as geometrical isomerism. Now this isomerism is also a configurational isomerism actually. Why? Because we cannot convert the cis isomer to a trans isomer by using mechanical force, because this double bond carbon-carbon double bond is a very strong bond. So we cannot rotate the molecule to change their configuration. Okay, what we have to do, we have to break the molecule and then we have to make that molecule again. Then only we can get the cis and trans isomer. Then another type of isomerism is there, that is called E and Z. So E and Z is similar to C and cis and trans, but it is not exactly that one. What is E and Z? Suppose if we have a double bond where we have four groups like this, Now we cannot measure by this molecule as cis and trans. Why? Because these two groups are different groups. Okay, in this case what will we do? Among these two groups, which one is the more preferable group? Suppose according to atomic number, this one is the highest, this one is lowest. In this side, this is 1, this is 2. Okay, now if the both ones are on the same side, then it will be called as Z isomer. Both the one group, first preference group, are present on the same side. If they are in the opposite side, suppose if it is like this, then it will be called as E isomer. So this is about E and Z. These are also configurational isomers, but they are categorized into geometrical isomers. Another type of molecules are there which can also be written in this category. Those are called pi diastereomers. Pi diastereomer. Pi diastereomer. Suppose if we have a cyclobutane molecule, here we have these two methyl groups. So these two methyl groups can also be written like this. So this type of molecules, cyclobutane, cyclopropane, cyclohexane, like this type of molecules, we can also write down cis and trans for this type of molecules. This is cis because these two groups are on the same side. This is trans. So this type of molecules are categorized in pi diastereoisomerism. Now come to another point, that is the properties of these enantiomers and diastereomers, or what is the difference in case of the properties. You can see the enantiomers have all properties same, physical properties like melting point, boiling point, refractive index, chemical reactivity, because they are also have the same type of configuration and their chemical reactivity is also same. But they have only one difference, that is optical property. Optical property means they can rotate a special type of light, and each enantiomer will rotate in a different way. That is their difference. Okay, now in case of the diastereomers, they have different properties. Like diastereomers, they have melting point, boiling points are also different, or they have different chemical reactivity, and this optical property is also different. So what we can understand from the properties, that in case of enantiomers, it is very difficult to distinguish between them because they have similar physical properties. But in case of the diastereomers, it is a little bit easier to distinguish between them. Okay, generally the enantiomers or diastereomers, in case of one molecule, suppose the mirror image of this one and the mirror image of this one, they generally present in a together. How can we understand that thing? That means suppose in a bottle we have a molecule like tartaric acid. Suppose that tartaric acid is having different enantiomers or diastereomer structures. So all those will present in that bottle only. In that chemical, all those will be present at normal temperature or something like that. So what we have to do, we have to separate them in different isomers. So this mixture of this all enantiomer or diastereomer is called racemic mixture or racemic modification. Now what we have to do to get a special type of isomer, suppose different types of isomers are there in that diastereomers or enantiomers. So to get a special one, we have to separate that racemic mixture. So that separation is a big process for get those type of enantiomers or diastereomers. So this is all about the stereoisomerism and symmetry that we have discussed today, and relationship in between them, and the different types of stereoisomers like conformational isomers, configurational isomers, and there are different types of those conformational configuration. I hope you have understood. Thank you.